Non-ideal solutions. What are non-ideal solutions? Solutions which do not obey Rolle's law over the entire range of concentration, they are called non-ideal solutions. Non-ideal solutions do not obey Rolle's law. Now, do not obey Rolle's law means the vapor pressure of such solutions is either higher than what predicted by the Rolle's law equation, or it is lower than that predicted by Rolle's law. If the vapor pressure of the solution is higher than predicted by Rolle's law, then it is said that the solution exhibits positive deviation, and if it is lower, then it exhibits negative deviation from Rolle's law. The plot of vapor pressure as a function of mole fraction is given here. Now this graph shows the positive deviation from Rolle's law, and this one shows the negative deviation from Rolle's law. The green line shows the graph for the ideal solution. The purple line shows the graph for non-ideal solution. Now in this case, the vapor pressure of the solution is greater than expected from the Rolle's law, and in this case the vapor pressure of the solution is lower than expected from Rolle's law. So this graph is of positive deviation from Rolle's law, and this graph shows negative deviation from Rolle's law. Now what is the reason behind positive and negative deviation from Rolle's law? Suppose A represent the molecules of solute and B represents the molecules of solvent. Now if the intermolecular attractions between AA and BB means the intermolecular attraction between the molecules of solute and the molecules of pure solvent are greater than the intermolecular attractions between A and B, means between the molecules of solute and solvent. In that case, since the intermolecular interactions between solute and solvent molecules is less than the intermolecular attraction between the molecules of pure A or pure solute molecules and the molecules of pure B or the pure solvent molecules. So what happens in solution phase, due to low intermolecular attractions, the molecules can easily go into the vapor phase, as a result of which vapor pressure of solution is greater than that predicted from Rolle's law, and thus these kind of solutions, they show positive deviation from Rolle's law. So in this case, solute solute interactions or solvent solvent interactions are greater than solute solvent interactions. Example of such solutions are ethanol and acetone. Now what happens in pure ethanol? There is hydrogen bonding between the molecules of ethanol. In pure ethanol, molecules are hydrogen bonded. Now when acetone is added, then molecules of acetone get in between the molecules of ethanol, as a result of which some of the hydrogen bonds break, due to which there is weakening of interactions, and a mixture of acetone and alcohol will have greater vapor pressure than predicted by Rolle's law, thus showing positive deviation from Rolle's law. Now in solution found by adding carbon disulfide to acetone, the dipolar interactions between solute solvent molecules are weaker than the respective interactions among the solute solute and solvent solvent molecules. This solution also shows positive deviation. Now what happens in case of negative deviation from Rolle's law? In case of negative deviation from Rolle's law, the intermolecular attractive forces between the molecules of A and the intermolecular attractive forces between the molecules of B are less than those between molecules of A and B. Now since the intermolecular attractions between the solute, the intermolecular attraction between the solvent molecules is less than the intermolecular attractions between solute and solvent molecules, what happens? Due to greater interaction between solute and solvent molecules, the tendency to go into the vapor phase decreases, as a result of which the vapor pressure of solution shows negative deviation from Raoult's law, or it is lower than that predicted by the Raoult's law. So in case of negative deviation from Raoult's law, the intermolecular attractive forces between AA and BB are weaker than those between AB and leads to decrease in vapor pressure, resulting in negative deviations. Example of this type is a mixture of phenol and aniline. This is the structure of, now this is phenol and this is aniline. In this case, the intermolecular hydrogen bonding between phenolic proton, this is phenolic proton, and lone pair on nitrogen atom of aniline. This is the lone pair on nitrogen atom of aniline. So here there exists a hydrogen bonding, is stronger than the respective intermolecular hydrogen bonding between similar molecules. Means the strength of hydrogen bond between phenol and aniline is stronger than the hydrogen bond between pure phenol molecules or pure aniline molecules. Similarly, a mixture of chloroform and acetone forms a solution with negative deviation from Raoult's law. This is because chloroform molecule is able to form hydrogen bond with acetone molecule as shown. Now due to this hydrogen bonding, the number of molecules going into the vapor phase, or the tendency of the molecules to go into the vapor phase decreases, as a result of which the vapor pressure of the solution is less than what is predicted by Raoult's law, and thus this solution shows negative deviation from Raoult's law.